Hello children, so welcome to my next video. So in this video we'll be discussing another important concept of class 9 chemistry, and that is the concept of mole. So we'll be discussing here about your mole concept. Now when we are talking about mole concept, so we'll be coming to mole concept little after a while. So before that, let us try to understand or visualize the concept of atomic mass and molecular mass. So in my earlier video I have explained to you that whenever we refer to atomic mass or molecular mass, we are actually referring to relative atomic mass or relative molecular mass. For example, suppose let's take an element which we commonly see around us, suppose iron. So we know that the atomic mass of iron is 56 U. So this is actually the relative atomic mass of iron. Okay, it means that an atom of iron is 56 times heavier compared to 1 by 12 part the mass of a carbon 12 atom. Now this number is a very simple number. It does not have any additional part or power to it. So it can be easily used for calculation. But when it comes to a practical purpose, so this is the mass of one atom. So one atom is very negligible or a very small entity. So practically it will not be possible for us to measure 56 U. So there is on a day-to-day basis, the different scales or the different weighing machine that we use, we cannot use those machine to measure 56 U. But instead of 56 U, if I tell you to measure 56 gram of iron, then it can be easily measured. So let us visualize. Let's take suppose I take iron powder. So suppose this much of iron powder is 56 gram, let's say. Now let's take another example. Suppose I take the example of suppose silver. There's another common element which we see around us. Suppose silver, its relative atomic mass is 108 U. So just like 56 U is too small an unit and cannot be measured, similarly 108 U is also a very negligible amount because it is the mass of one atom. So physically or practically you cannot measure it. But instead of that, if I tell you to measure 108 gram of silver, then it can be easily measured. So the amount will be almost let's say the double of this. So this much amount of silver. Now let us come to one more element. After that we'll be going to compounds and molecules. One more commonly seen element around us. Okay, let us take copper or magnesium ribbon. You have seen in fireworks the sparkles. So there are small pieces of magnesium. If you haven't seen magnesium in lab also, the sparkles that we burn in Diwali, so they have small silver color pieces inside the sparkle, and those are actually magnesium ribbon. So magnesium is another element. So the mass of magnesium is 24 U. One atom of magnesium relative atomic mass is 24 U, and so this 24 U is very negligible. But if someone tells you to measure 24 gram of magnesium, then it can be measured. So let's take, suppose this much will be 24 gram of magnesium. So what I am doing is that I am converting the atomic mass, that is the relative atomic masses, into gram. I am expressing them in grams. So then it is called the gram atomic mass. So what is gram atomic mass? The atomic mass means relative atomic mass. The atomic mass of any atom, when expressed in gram, it is known as the gram atomic mass. Now we come to molecules. Okay, so all these were the examples of atoms. Now let us come to the example of molecules. Suppose we take a common molecule which is found around us, due to which we are actually surviving. Let's take the case of oxygen molecule. So O2 means it is a molecule of oxygen which is made up of two atoms of oxygen. So its molecular mass will be 16 into 2, that is your 32 U. Now just like the relative atomic mass was very negligible and practically it is not possible to measure it with the help of the devices that we have around us. Similarly, 32U will also be difficult to measure, but instead of 32U, if I tell you to measure 32 gram of oxygen, then it can be measured. So okay, that because I have drawn a solid heap and oxygen is gas. Let's take one more example where we can be considering it in the form of a physical amount. Suppose we take calcium carbonate. Calcium carbonate is 40 is calcium plus 12 carbon plus 16 into 3. So if you do it, you'll get that it is your 100U. So one molecule of calcium carbonate is commonly called chalk, the chalk which we use to write on the board, or marble, the marble on the floor, limestone, all these are different names for calcium carbonate. So the mass of calcium carbonate, one molecule of calcium carbonate is 100U. So just like these masses were difficult to measure practically, similarly 100U, that means one molecule of calcium carbonate will be difficult to measure. So instead of that, if I take 100 gram of calcium carbonate, then it will be easier to measure. So let's say 100 gram of calcium carbonate is this much of amount. Let's take one more common compound found around us. Let's say sodium chloride, common salt. So sodium chloride will be 23 plus 35.5. So that's your 58.5U. So one molecule of sodium chloride is 58.5U. That's the mass, molecular mass of sodium chloride. Now, just like these were difficult to measure, similarly one molecule of sodium chloride will be practically difficult to measure. But instead of that, if I take 58.5 gram of sodium chloride, then that can be measured. So what I am doing, I am converting the molecular masses into gram. So molecular mass when expressed in gram, then it is known as gram molecular mass. So this is the two concept of gram atomic mass and gram molecular mass. What is gram atomic mass? The atomic mass of any atom of an element expressed in gram is called gram atomic mass. Similarly, what is gram molecular mass? The molecular mass of any molecule. It can be a molecule of an element or it can be molecule of compound. When expressed in gram, it is known as gram molecular mass. So now we come to, now what we find here. Now comes the most interesting part of mole concept. Now what we find, if you are visualizing the amount is different for different substances. When we are taking their gram atomic mass or gram molecular mass, the amount varies. Okay. But the most interesting part, which was discovered by the scientists, and that is regarded as one of the most important discoveries in chemistry. So it was found that even though the amounts are different, but the number of particles which will be present inside this much of amount, the amount which is equal to gram molecular or gram atomic mass, will be exactly same. Same number of particles are there. And what is that number? That number is 6.022 into 10 to the power 23 particles. Now when we say particles, particles may mean atoms, molecules, or ions. So this much amount of magnesium, that means 24 gram of magnesium, will contain these many atoms of magnesium. Similarly, 32 gram of oxygen will contain these many molecules of oxygen. Okay. Then 100 gram of calcium carbonate, amount is more, though the amount is more, but that will also contain these many molecules of calcium carbonate. That is the beauty of this number. So you can imagine, there are 118 elements and there are millions of compounds. And if you take the atomic mass or molecular mass of these elements or the compounds, the gram atomic or gram molecular mass of that particular substance will contain these number of particles. So it is such a beautiful constant number. And this number is called the Avogadro's Avogadro's constant. It is represented by Na, or in some book you might also find N naught. Okay, whatsoever. Now this, a collection of these many particles is known as 1 mole. So what is mole? Mole is nothing but a collection of 6.022 into 10 to the power 23 particles. And from these examples that we have found that these number of particles will be present in what? Will be present in either the gram molecular mass of that substance or gram atomic mass of that substance. So 1 mole is equal to Avogadro's number or Avogadro's constant, which is equal to the gram atomic mass or gram molecular mass of any substance. So this is the relation that we are getting. So based on this relation, we can do different types of sums or calculations, like converting mole to particles, particles to mole, or mole to mass, mass to mole, or particles to mass or mass to particles. So 6 different types of sums or your problems can be done. Now for example, suppose if I take O, one atom of oxygen, its mass is how much? 16 U, and its atomic mass will be 16 gram, atomic mass will be 16 gram. So 16 gram of oxygen will contain these many atoms, will contain 6.022 into 10 to the power 23 atoms of, or oxygen atoms, you can say oxygen atoms. Now if I say O2, O2's mass is 32 U. Now what is O2? O2 is a molecule. This is the molecular mass. So 32 gram will be the gram molecular mass of oxygen. This will also contain 6.022 into 10 to the power 23 particles. But what will be the particles? It will be not atoms, but it will be these many molecules of oxygen gas. So that is the concept of mole. Now a very simple example, suppose if I say 1 mole, suppose what is the mass? If I say what is the mass of 5 moles of nitrogen gas, N2. So we know N2, mass of N2 will be 14 into 2, that is 28 gram. So 1 mole of nitrogen is your 28 gram, because nitrogen's atomic mass was 14, so 14 into 2, that is 28. Therefore how many moles are given? 5 moles. So while doing any numericals based on mole concept, your unitary method needs to be applied. 1 pencil costs 2 rupees, what will be the cost of 10 pencils? Or 10 pencils cost 20 rupees, what will be the cost of 1 pencil? Something like that. So 5 moles of nitrogen, what will be the mass of 5 moles of nitrogen? It will be 5 into 28. So whatever you get, that many grams. So this is the concept of mole. So basically when we say mole, mole means it is a collection of these many number of particles, which is equal to the gram atomic mass or gram molecular mass of any substance. So in class 9, this is the concept of mole that you need to develop. I hope the concept is clear to you. If you like the video, do share it and click the bell icon for the further notifications. Thank you so much.